Hello, this is Mrs. Ward, and I am going to explain the second half of the assignment for section 9.6, which is polar coordinates. So we're going to start with number 41. And 41 says use a graphing utility to find one set of polar coordinates for a point given in the rectangular coordinates. So there are many correct answers. I'm just going to show you how to find the most basic one. So this is my X and my Y because they tell me it's in rectangular. And when I go the polar, I want to find my radius and I want to find my angle or my theta. So remember that r squared is equal to x squared plus y squared. So I'm going to find my radius first. So I'm going to say r squared is equal to 5 halves. That's my x squared plus my y squared, which will be 4/3 squared. When I square these and add them, I definitely did that on my calculator, I'm going to get 289 over 36. And when I take the square root, I'm going to get a radius of 17/6. Now I'm going to go ahead and find my angle. So remember, to find theta, they tell you that the tangent of theta is equal to y over x. So I'm going to start with the tangent of theta. My y in this case is 4/3 over my x, which is 5 halves. So to do this in my calculator, I'm going to do the inverse tangent. And then I'm going to do, that's a parenthesis, very bad parenthesis. I'm going to do 4/3 divided by 5 halves. So 4/3 divided by 5 halves. And when I do all that, I end up getting my answer in radians, which is about, my calculator gives me 0.489995. So I'm going to say approximately 0.49. We'll say 2 decimal points is good. So now now if I were to write this, I would say my radius is 17/6, or the decimal for that I think is 2.83, and my angle is 0.49. If you want to change that to degrees, you can either do the DD button on your calculator, or you can multiply by pi over 180, or 180 over pi, sorry about that, and you end up with 28.1 degrees. Either one of these answers is fine. That's what you get. I like to do a double check, because if you remember, my inverse tangent can only give me an answer for my first and my fourth quadrant. So this angle is in my first quadrant. This ordered pair, 28 degrees, is in my first quadrant. The radius is positive. So this is also my first quadrant. So those two match. If they don't match, in other words, if your original point was a point that was in the second or the third quadrant, remember that's where you have to add pi. Add pi, or you add 180 if the coordinates don't match, if the quadrants don't match. But I don't have to worry about this because that's in quadrant 1. So let's do the next one. Okay, 46, they wanted me to convert the rectangular equation to the polar form. And going from rectangular to polar is I think very simple, because there's only one thing you can do. And if we're going the long way about this, every place I see y, I'm going to write r sine theta. Every place I see x, I'm going to write r cosine theta. So if I do this, I'm going to say r sine theta is equal to r cosine theta. So if I divide both sides by r, I'm going to have sine of theta is equal to cosine of theta. And let's say I divide both sides by cosine of theta. Well, sine divided by cosine is tangent, so I'm going to say the tangent of theta is equal to cosine divided by cosine is 1. And then when is it? So then you're basically doing the inverse tangent of 1 is equal to theta. And so theta is going to end up equaling pi over 4, or 45 degrees. Don't know the decimal. A lot of you probably wouldn't have done all this. You probably would have just right here divided both sides by x, and you would have remembered that y over x is equal to the tangent of theta. But this is just doing the cookie cutter thing every single time. When I do the next one, I could change this r squared cosine squared, r squared sine squared. But I remember that x squared plus y squared is equal to r squared. So I'm going to write r squared, and that whole thing is squared, is equal to 9, and then x squared minus y squared. Now I'm going to go ahead and change these two. They're not plus, so I can't make them r squared. Whenever I take a square to the square, this will be r the fourth is equal to 9. And then this will be r squared cosine squared theta minus r squared sine squared theta. Now here I have an r squared, so I'm going to factor that out. So I'm going to say r the fourth is equal to 9 r squared. And then cosine squared theta minus sine squared theta. Here now I can divide both sides by r squared. So when I do that, r to the fourth divided by r squared will just be r squared is equal to 9. And then that's a 9. And then the cosine squared theta minus sine squared theta. Now, when you go to check your answers, you're not going to see that in the back of the book. You're going to see r squared is equal to 9 and then cosine 2 theta. And that's because they're hoping that you remember from chapter 5 in trig, your double angle theorems, where cosine 2 theta is equal to cosine squared theta minus sine squared theta. So the book expects you to get here. I am so very, very happy if you guys get here. That's fine. But this is how the book gets to there. Okay, the next one I have x squared is equal to x cubed. So if, let's say I had no idea how to start this one, so I'm going to just start with r squared sine squared theta, because replacing any place I see a y, I'm going to replace it with that. And then this would be x cubed times cosine, that's a cosine cubed theta. Then what I realized is I could make this r squared. Oh, that's not r cubed. So, sine theta. And then let's say I divide both sides. Let me show you what I'm going to do. I'm going to divide both sides by r squared cosine squared. So I'll have r squared here, cosine squared. Well, and that sign should be squared, is equal to, and then here when I divide r to the cube divided by r squared, that'll just be r. Cosine cubed divided by cosine squared will just be cosine theta. And the reason why I did this is because here the r squareds will equal 1, and then sine squared over cosine squared is tangent squared. So tangent squared theta is equal to r cosine theta. Now, all of these, if I can, are set equal to r. So if I want to set this to r, I'm going to divide both sides by cosine. So remember in trig, we don't write that division by cosine. We wrote it times the reciprocal. And the reciprocal of cosine is secant. So I'm going to have secant theta times the tangent squared theta is equal to my r. And that's going to be my final answer. Again, up here, if you would have divided by x squared, you would have gotten the exact same thing. So going from rectangular to polar is fairly easy, because if you're stuck, what you're going to do if you don't recognize anything is you're always going to replace y with r sine theta, always replace x with r cosine theta. What gets tricky is when we're going from polar to rectangular, because then I have to sort of become more creative, because there's so many different ways that I can do this. So here I have theta is equal to 11 pi over 6. So I remember that tangent of theta is equal to y over x. So what I'm going to do is I'm going to say, well, the tangent of this angle, the tangent of theta, is going to equal y over x. So this angle is 11 pi over 6. So I'm going to say the tangent of 11 pi over 6 is equal to y over x. Okay, well, the tangent of 11 pi over 6, I don't remember that off the top of my head, but I do remember my unit circle. And I remember that the sine, remember it's sine over cosine for tangent. So the sine of 11 pi over 6 is a negative 1/2. The cosine of 11 pi over 6 is the square root of 3 over 2. So when I multiply by the reciprocal, the 2's simplify, and I'm left with negative 1 over the square root of 3, which I would write as negative square root of 3 over 3. So that's my tangent, and that's equal to y over x. So I'm going to say negative square root of 3 over 3 is equal to y over x. Solving for y, I'm going to multiply both sides by x. And when I do that, I'm going to bring the y onto this side. I'm going to have y is equal to negative square root of 3 over 3 times x. And that's the equation of my graph. Okay, the next one I have number 77. I have r is equal to 1 over 1 minus cosine. So I don't like having anything in the denominator, so I'm going to get rid of that first. I'm going to multiply both sides by 1 minus cosine theta to get rid of that denominator, 1 minus cosine theta. So when I do that, I'm going to end up with r times, so this will be r minus r cosine theta. And then over here, these will simplify, and that's equal to 1. I remember that r times the cosine theta is equal to x. So I'm going to have r minus x is equal to 1. Bring the x over the other side, so I'm going to have r is equal to x plus 1. Then it's still not rectangular because I have this r. So there's two ways I can have r times sine or cosine to replace it with x or y. Or I know that r squared is equal to x squared plus y squared. So I don't want to multiply by sine or cosine because that's going to bring sine or cosine over here, and that's not going to get rid of the polar. But if I take this and I square this side, which means I'd have to square this side, I would have r squared, which I can rewrite in terms of x and y. And then this squared will be x squared plus 2x plus 1. So r squared is equal to x squared plus y squared is equal to x squared plus 2x plus 1. I'm going to start by subtracting x squared from both sides. And when I do that, I'm going to have y squared is equal to 2x plus 1. And there's nothing else I can do with it. I'm hoping that you recognize this shape from conics. Since the y is squared and nothing else is squared, you should recognize that this is a parabola. And we'll go through more with that later. And then the last one, number 80, you have r is equal to 6 over 2 cosine theta minus 3 sine theta. Again, I don't like having anything in the denominator, so I'm going to multiply both sides by the denominator to get rid of it. So I'm multiplying both sides by 2 cosine theta minus 3 sine theta. So I'm multiplying this r by the same thing, 2 cosine theta minus 3 sine theta. When I distribute the r, I'm going to have 2r cosine theta minus 3r sine theta. And then here, these will simplify, and I'll be left with 6. Remember that r cosine is equal to x, r sine is equal to y. So I'm going to have 2x minus 3y is equal to 6. You can leave it like that, or you can solve for y. So I'm going to bring this over. I'm going to bring this over. So I'm going to have 2x minus 6 is equal to 3y. Divide everything by 3 to put in slope-intercept form. 2/3 x minus 2 is equal to y. And that would be the equation in rectangular form. So if you have any questions, let us know, and hope this goes well.